Hello, I'm Brandon Lowe.
And I'm Colin Devaney, and this is our ECE2001 laser transmitter.
We decided to have our microphone circuit over here, our audio circuit over here, and it gets gained separately into a summing circuit. Our bias T is here. We have our voltage divider, and then it goes off towards the laser here.
Of our project right here is our microphone circuit. We basically took it from our earlier lab, and we're biasing the microphone with 4.5 volts to this resistor here. And then we have 5 microfarads equivalent capacitance right through here. And then if you move it over a little bit, we're going to be amplifying it using an op amp with a gain of 100. And then from here, this goes through this orange wire into our summing circuit.
Control, we have the positive going in there, negative going in there. This comes all the way over here, which goes into this op amp, which has a gain of 10. After the gain, it comes all the way over here and meets up with the microphone circuit to our summing circuit.
Here is our op amp that's going to be doing the adding together of our signals. So in these 2 wires is the input from the MP3 player and the microphone. We're using these 3 capacitors here to reduce noise and static that we don't want to hear. And then our gain right down here is just about 1. We found that the best to reduce noise and have a clear signal.
We have our capacitor here, which cuts out any DC voltage from the summing, and it only allows the AC portion to pass. This AC portion is then biased in our bias T for the baseline to power the laser. We have it coming from 9 volts. This resistor here maintains current. It makes sure that we have enough current to power our laser. And from here, this blue wire comes off. We have to our laser. The ground goes to the ground all the way into our battery ground, and we used a different ground for the whole circuit in order to make 4.5 and negative 4.5.
So here we have the 9 volts from the battery coming in, and this is the ground of the battery right here. We're basically dividing the 9 volts into 2 to get 4.5, but we're grounding right here at 4.5, so that we're going to have positive 4.5 right here, and negative 4.5 down here. And we're going to be able to use this in our op amps to get the voltage we need.
We have our photo cell that comes in here. We have a capacitor right there to filter out any unwanted noise. It then comes into the LM386, which is biased with 9 volts. And it comes off of that. The capacitor there adds gain. This capacitor right here on the 1 and 8 terminal of the LM386. This off the output, it is connected to our speaker, and there's a resistor in series with the speaker to protect the speaker from blowing out. But this plays the music that we transmit over the laser. Underneath there, we have the laser sticking out of there to balance it, so it's lined up right with the thing. And we're gonna play some music. Go ahead. We'll go down there. You should be able to hear it. You can hear it now. We got some T-Swift. All right. Now. So.
I disconnected the audio from the MP3 player, and I'm just talking to the microphone.
Okay, so here we have our whole final sending circuit soldered to the solder board. We have the clip holding the laser, so it's powered. We're going to play some music, give a final demonstration over to our soldered receiving circuit. Here it goes.